Music passed away recently, and I know Chris has a couple of things to say about that. So I think turn it over to Chris.
Yeah, just a very few things to say. This wasn't on the agenda, obviously. Professor Gusick had been suffering apparently from cancer and was doing fine. And we've heard the story, a million times before. He was doing just fine, and then the last few weeks, maybe a month and a half, month, 2 months, he went into a downward, that he didn't recover from, and he chose, to stop the treatment and just live out his days, not going through all that mess. I don't know if any of you ever met Professor Gusick. He was our liaison for the longest time until he gave up that position to be the head of the Louisiana Space Research. And he's got a very nice wife named Jane, 3 kids. One of his kids was the one who stenciled those sayings on the stairs. And he and one of his sons actually, we got to reload. I keep saying we're going to reload all the old video and audio from the old website, but they actually put in an algorithm upstairs and tracked the ISS. And so
it's still on YouTube.
It's still on YouTube.
In the last email newsletter we just put out, we included a link to that.
Oh, that's fantastic. Good. And I'm hoping I can get a little task force together to do that again and see if we can duplicate that. Professor Gusick was a very driven man. He was gruff at times. He was no nonsense, but he had his hand in a lot of successes. HRPO was the biggest one, in my opinion, for the local area. He and Nolan Hare, Walt Cooney, and a few other people made this happen. This place wouldn't be here without him. It was his audit, or his response to an audit, from the state that resulted in the state declaring that the physics department needed better observing equipment. And so he got hold of Board of Regents moments and for the base amount to pay for this place right out. Of course, he was also involved with the Ag program, which hunted cosmic rays from the Antarctic, and the ACES. I can't remember which acronym, but the Student Bloom Project, HATS. The Student Bloom Project that they went all the time to Palestine, Texas. He was a very driven man. He believed very much that giving people access to scientific places like this enhance their lives, maybe even make their lives more meaningful. I think that's true too. He also had a very soft side. He actually surprised his wife here one night with a singing quartet. That was very nice. I don't know what the occasion was, an anniversary maybe or something like that. But he liked animals, he liked kids, he liked the families coming over, and he was very appreciative of people like Trey Goodman and Dottie Hartman and Wally Purcell and all of you keeping this place alive. So we're definitely going to keep doing that. We have our 40th anniversary in 2 falls, and so we're definitely going to be thinking about when we're going to head out on the road there, and hopefully all the shakeups happening in Breck will be a net positive for the observatory. It looks like so far they are.
Yeah, the plan is to we will try and have some sort of either just a slideshow or do some sort of little just brass-wise a little memorial slideshow thing that we could show at our December meeting when we have lots of people here and people that only come out once a year to the December meeting. Some of those people are people that knew Randy. So that should be good. All right. A lot of new faces here and whatnot, but we'll get to all of that kind of stuff after our talk. We're going to have our talk. We'll do a short little intermission where you can maybe a little bit, ask some questions of our speaker if you were too nervous to raise your hand or interrupt while he was talking. And then we'll come back and do our normal club business. And at that point, please stick around. It should be a clear night. We'll take out some sea stars and we'll take out some telescopes, and you're welcome to stick around and do some observing with us. So, but without any further ado, I'd like to introduce to you our guest speaker for the month. We're honored and very pleased that he came out to speak with us this evening. This is Dr. Carlos Gary-Bicas from LSU's Department of Physics and Astronomy.
I'm actually just going to speak like this to keep it a little bit more informal. So I'm going to give you all a little bit of background of what I do and who I am. I'm actually not in astronomy and physics, although what I do is technically astronomy and physics. I'm in the Department of Geology and Physics. I was trained as a planetary scientist. I started out as an astronomer, so I got a degree in astronomy at CU Boulder. Then I figured it was too difficult to do astrophysics, so I went to the next easiest thing, which was planetary science. I got a degree in planetary science at Stony Brook University. Right now I'm a postdoc in the Department of Geology and Geophysics, where most of the research that I do either involves astrobiology or geological characterization of the crust and surface on Mars. So I use data sets spanning from the infrared all the way up to gamma ray on orbiters that are currently, hopefully, they still currently orbit Mars. I basically take that data and try to squeeze as much out as I possibly can to try to understand what's happening in the planets. And so when people find out that I do astrobiology and geology and planetary science, the first immediate question I get is, are aliens real? So I think this talk that you're seeing now, I actually gave it at Astronomy on Tap a couple months ago. And the reason I decided to do this talk is because it's a fascinating thing for me and for everybody that's interested in these things. And I think it's also a way to sort of pique curiosity from people in the subject and get them to learn. And so the title of the talk is Our Cosmic Oasis and the Search for Life Beyond. And I always start out with this quote by Arthur C. Clarke, where he said, there are two possibilities that may exist. Either we are alone in the universe or we are not. Both are equally terrifying. Great quotes. And yeah, I did put my own spin on it, and I said that the possibility that we are alone in the universe is equally terrifying and humbling. This universe is so expansive, it's so big. It's statistically more likely, at least to me, that there is life in some form or other than just, Earth being this unique place in the entire universe, as big as it is, that can harbor life. So we can sort of chime in or go into, again, I'm an astrobiologist, I'm not a biologist. If there are biologists in the crowd, I'm really sorry about this. But we can sort of categorize in astrobiology life in three categories. You have insentient life, life that is alive but cannot feel; sentient life, life that can feel but cannot think; and then sapient life, can feel and think. And these are really good examples of what that looks like, right? So insentient, you would think microbes, bacteria, etc. Now viruses. A biologist told me you can't call a virus living. Okay, I get it. Sentient, you would think about your puppy, and then sapient, you would think about us. This is a running joke that I have. If we're gonna have to censor adults, we have to censor everybody. Right? And so we have to be equal with everybody. But interesting thing about that, and I think a lot of you will know, but if you don't, bug me later as to where I took this picture of human beings from, because
I know exactly.
I figured as much. This is a very special, for me, it's a very special. I actually have a very personal relationship with that specific figure. You can ask me later about that, and I'll show you how. But we're going to start exploring the possibilities of these three types of life in our solar system, the closest that we can explore first. So we're going to start with intention life, right? And so there are three celestial objects or three bodies that immediately pique our curiosity when it comes to intention life. Mars, of course, Venus, and Titan. And so these are the astrobiology targets, biggest targets for both NASA and other space agency missions, right? Now, in terms of where it may occur within these three bodies, well, we can begin with Mars. So Mars definitely does not have any signs or possible life existing on its surface. There is too much solar radiation that would just cook and kill anything. So the surface is sterile. But if you dig deep underground, let's say the probabilities of finding life are higher. Not only because it's protected, life might be protected in the inner crust on Mars, but also because there are specific signatures, mainly thermal. This is what I work on specifically at LSU, that would provide the adequate temperature ranges for microbial life to survive on the surface. There are added possibilities. Water could be definitely locked in both in the subsurface and the crust, either in the form of ice or just liquid water. So the old NASA saying you want to find life, follow the water. We're kind of having to switch that up a little bit. Water doesn't necessarily mean life, but there are other aspects that need to be taken into consideration. One of them being temperature. On Venus is a very peculiar place because microbial life may survive on Venus, but it's not going to survive on the surface of the planet. It's actually going to survive in cloud bank. There is a specific part in its atmosphere that the pressure and temperature is adequate enough for microbial life to survive. There's even a stipulated theory that a meteoritic impact that might have hit Earth could have transported microbial life from Earth to Venus and its atmosphere. And lastly, we have Titan, which is the probably most convincing of all of these, if you ask me personally, for harboring life. So first and foremost, the atmosphere is organically rich. There's a lot of organics in the atmosphere that could point to the possibility of life. Secondly, it is slated to have a underground ocean, like a water ocean. So that's another possible region for microbial life to survive. So, we can guess all we can or all we want, but the idea is to actually figure out if life does exist in space. Now, as you may know, we have done a lot of efforts on Mars to try to figure out if there is life. My biggest takeaway, or my 2 cents, just looking at the crustal composition on Mars, is with the missions that we have sent so far, it's going to be extremely unlikely that you're going to detect life on Mars. And the main reason being is the instrumentation that we have implemented does not penetrate deep into the crust. It's too shallow. And so while we have enticing findings of organics from missions like Perseverance and Curiosity, there's not enough evidence for us to say that there's what we call extant microbial life on that part of Mars. So the mission, or the next step, is to send a mission that can penetrate deeper into the subsurface of Mars. And technically speaking, here at LSU, we are working on starting to do a pitch for a mission of that caliber. Obviously, we're trying to work with partners outside of LSU, but my advice and myself are working diligently to start up a mission that is LSU-led to do a probing on the subsurface on Mars. You can ask me all about that later. I have too many hot takes on that. The next mission is the NASA Da Vinci mission. This is probably one of my second favorite mission of all time. So the mission, basically how it will go is we will actually send a balloon with a probe. You're looking at the probe right there. and we're gonna float that balloon on the atmosphere. There's gonna be instrumentation inside the probe itself to try to see if they can detect microbial life in the atmosphere. And it's slowly gonna sink to the surface and then obviously die because it's not gonna be able to withstand temperatures and pressures. But this is a very enticing mission. If everything goes well, I'm not going to get political, but if everything goes well, the mission should get to Venus in 2031. And so in less than a decade, we could find out if there's life on Venus as well. The last mission, and this one is definitely a mission that we know for a fact, regardless of anything that's going on this weird blue planet, that's going to fly is NASA's Dragonfly mission. And it's probably the coolest concept I've ever seen in the history of missions. I'm flabbergasted that this got approved and it's flying. It's a helicopter that is going to be hopping throughout all of Titan. And it'll have different instruments to do detections of different compositions as well as microorganisms if there are any. The reason this is so flabbergasting to me is the amount of risk that exists in a mission of this caliber is huge, but NASA still went for it, and it's flying. And it's probably going to get to Titan roughly around 2035, maybe even later.
Good question. Why not Europe?
I'm going to get to that. So right now we're in the microbial life section, the sentient life. But you just gave me the best segue ever. So sentient life, so life that can possibly or probably feel. Our best candidates are both Europa and Enceladus. There's other Galilean moons, Enceladus not being a Galilean moon, but Ganymede is also a possible moon. These are what we call ocean worlds, and I mean by ocean worlds I don't mean SeaWorld or the 1999 Kevin Costner Water World movie. No, by ocean worlds I mean worlds that contain water, either the Earth's surface or deep buried in the crust. And so the figure that you're seeing here on the left is every place that we have high level of confidence as having underground ocean. Now, I want you to pay attention to the sphere that's on the bottom right of all of them. That's the water volume that exists at all of these, and these are compared with each other. You will note that the majority of these have higher water volumes than Earth itself, right? Crazy. The other aspect of it, and this is something we don't know yet, is there's two possibilities for the ocean water, like the ocean worlds to develop. There is a possibility that you have a slush, like a top layer of crust ice, and then below it you have slush. It's just warm convecting ice. And the other possibility is that you have liquid ocean under it. And so we don't know what either of these scenarios exist in any of these regions. You mentioned Europa. We're on our way. We just sent the NASA Europa Clipper mission. It's going to do several flybys and orbits to try to do compositional detections both on the surface and try to probe to see what it looks like on the subsurface. Unfortunately, there was a stipulation. There was a possibility we were actually going to send a lander with the mission, but it was unfortunately canceled. But the chances for a lander still exist. Now I'm going to pop in, and this is a concept that y'all probably know already. But you know, when you're thinking about the ice versus water scenarios, the main question you have to ask yourself is how are these moons kept warm enough for water liquid not to freeze? Because they're too far away from the sun. They receive significantly less solar radiation than Earth or even Mars. So how is it that these moons keep warm? And so the biggest concept I learned in astronomy and planetary science is, orbital resonance and tidal heating on these objects. And you might be more acquainted than the folks at AOT, but this is probably the most interesting concept that I've ever seen in astronomy. So essentially what happens is, in order to keep these moons warm, you need to compress and stretch them. And this is actually happening. When you're orbiting an object as massive as Jupiter, you're going to be stretched and compressed, especially because you have what they call an elliptical orbit. Your orbit is not perfectly circular. So there are going to be points in the orbit where you're going to be closer to Jupiter and stretch more, and points where you're going to be further from it. So that stretching and compressing basically creates enough friction to generate heat for the planets, the moons themselves, to be warm. Now, the Galilean system is the most interesting system ever because, as you can see here, they have orbital resonances. So the parities of the orbits that you see between the moons themselves are in perfect synchrony. And so you can think about it in the same manner as, imagine there's an earthquake and the building has a significantly similar resonance than the earthquake waves themselves, then the building is going to shrink more. And so what's happening here is the combination of the orbital resonances, the tidal bulging, and you also have to remember that although Jupiter will exert a significant amount of gravitational pull on the moons, the other moons will exert that gravitational pull on the other moons themselves. And so between the stretching of Jupiter and the other moons and the resonance that exists between these orbits, it is extremely likely that they're warming. And the other aspect of it, anywhere in our solar system that has semi-terrestrial or terrestrial crusts will have a radioactive isotope. And so the decay of these isotopes, like uranium that we're seeing here, is also a warming agent. So the moon-like series, the dwarf planet-like series is kept warm because of radioactive decay. So combine that with possibilities of water, and you have possibly one of the greatest combinations for warm water ocean worlds. Sorry, I said water worlds. Warm ocean worlds where closer to the bottom of these oceans, you will have enough warmth generated through hydrothermal circulation that it's going to create what are known as hydrothermal vents. We have those here on Earth, right? And the idea is it is possible for this to happen, very likely to happen in these ocean worlds. And so hydrothermal vents are super, super important because A, you're warming up the ocean, and there's also exchange of materials. For example, organic materials that may exist in the crust are ejected by these hydrothermal vents. And so you're populating a warm ocean world with organics, and this is sort of like the perfect combination for life to thrive. Now, the reason I'm cataloging this as sentient life is because the likelihood of sentient life to develop in this environment is significantly higher. We see this in our own planet, right? And so, unfortunately, what we're sending now is not going to give us enough information to be able to detect this. Maybe it will. But if the conditions on the surface are good enough to corroborate these hypotheses, then there could be an interest in exploring these further.
If you sample and the material coming out of it, yeah.
It would be the greatest scenario in history if they found. The problem with that is they're so unpredictable, and so you need to get extremely lucky for it. They're going to be orbiting for a couple of years, so the likelihoods could be high. But yeah, it would be insanely amazing to be able to sample for them. And the Enceladus had a few jet expulsions before, and what they've done is they've done some spectroscopy to try to see if they could detect organics. There were some false negatives and false positives. They were not convinced, but we're keeping our fingers crossed for sure. And as I mentioned, we're sending the Europa Clippers already on its way. I'm trying to elbow my way in to work with them. They won't let me, but I'll see their way. And then hopefully we'll get some enticing results for sure. Now we go into the last one, sapient life. So now we're going to play a game of statistics for math. The chances for sapient life to develop in our solar system itself, I said pretty slim, but where it is. the geology and physics that we have in our solar system basically has given us the correct conditions for life as we know it to exist here on Earth. There is no other environment in our solar system that would remotely be able to sustain the quality of life that we have. And so the reason I titled this talk as an oasis is because it's an oasis for us. Microbes will survive almost anywhere. Possibly aquatic life in these moons, but for humans, it's all we have. So the closest place that we could possibly see similar conditions as Earth is Proxima Centauri b, which is 4.2 light years away. I mean, unless they're lying, right?
I love it.
But jumping back to Proxima Centauri b. So this is a very interesting system. I think you might all know this already, but this is a system that has 3 suns. So if you're a Star Wars fan, they already took Tatooine away from you, and there's an even cooler place. But it's 25 trillion miles away. I don't even know how to fathom that number, right? But looking at the technologies that we have in terms of rockets that we have built, the Solar Parker probe actually just broke the speed record in our solar system. So at that speed, it would take us about 6,500 years to get there. Now, if you're looking at these like super shiny cool rockets from this space company that I'm not a big fan of, and I will not mention, but you get the gist, it would take close to 20,000 years to get there. So, yeah, it's not super feasible, at least with the technology that we have. I can't speak to like the technology that we don't have, but as a scientist, it's my responsibility to try to explore all possible hypotheses. And so, out of the 2 places that I could check out was either Area 51 or Roswell. I'm not allowed at Area 51. Most of us aren't. So I decided to take a trip to Roswell, New Mexico, and see what was happening. And I did have a close encounter of the weird kind. It was at my Motel 6. It was scary at the beginning, but then we became close friends. And so I went out that night. Interestingly enough, Roswell, if you go out north of Roswell, you will have one of the darkest skies in the entire country. And so I was like, all right, I'm going to do some stargazing. I didn't have a telescope at the time, but I was like, I mean, my eyes will do it if it's dark enough. I waited for a couple of hours, did not get abducted, so I returned to my Motel 6, very disappointed, but the next morning I decided to go to a McDonald's close by where I found this guy that seemed to be indulging in a specific substance that is legal in the state of New Mexico. So to conclude, there is, I would argue that there is a high likelihood that there is life in our solar system. It probably will mostly be insentient, so microbial. There's a possibility that it's sentient. There's this object that's coming and visiting us, 3i Atlas, right? I'm sure you've heard of it, and like the immediate reaction that I got from family members is like, is it them? And I'm like, no. The answer I gave them was, human beings are not cool enough for them to come and see us. We need to improve that. Roswell, New Mexico, while really cool, very weird place, we cannot reach anywhere nearly as close as life-sustaining as useful as our Earth is. So we're extremely lucky. The tip your server and bartender, I don't know if there's an open bar here.
We got sandwiches.
Okay, tip your sandwich maker now. And thank you so much. I'll take questions.
Any questions?
What would be your conclusion if you found an exoplanet that had a strong oxygen signature? Well, conclude there'd be life there, because oxygen cannot exist very long
Right.
without a source.
Right.
And it seems like life is in much logical source for oxygen to generate.
I mean, there's a high likelihood that there could be life, but like if you look at our own atmosphere composition, we're mainly nitrogen. Our atmosphere is mainly nitrogen, so about 70 something percent. And so a rich oxygen atmosphere, I would argue, is something closer to earlier stages of Earth's atmospheric environment.
It supported life in.
Yeah.
Yeah, we wouldn't. It makes other life.
Yeah, I mean, the ideal like detection would be a combination of oxygen and organics. And so by organics, usually like methane is a good indicator. Methane is something that became very popular on Mars for a little bit because there was like methane detection, and everybody was like, "Oh, it's life." It wasn't. It was a byproduct of the chemical reaction. Um, it has to be this Goldilocks idea of like, yeah, there might be oxygen. Water is also very important, and the temperature at that specific orbit needs to be present for that. Temperature is, I would argue, I know this as a thermal physics person, temperature is the most important thing. Always. If it's too cold, doesn't matter. If,
Right, no,
yeah, you're not, unless life adapted to survive that way. Yeah, the thing about it is, and again, I'm hoping there's not a lot of biologists here, but there's a lot of chaos that goes into evolutionary trends for anything. So like even our own evolutionary chain was so chaotic. Some evolutionary biologists say that if it got restarted exactly as it started before, it would not be exactly the same right now. Right? And so we don't know. No. But it could be. Yeah.
You ever thought about the possibilities of life based on something other than carbon?
I had this question before in the Astronomy on Tap talk. I mean, the immediate thought is silicon-based, right? Yeah. So I'm going to argue this. As a geologist, it's very hard to convince myself that there could be silicon-based life because most of our crusts are silicate, like even Earth, Mars, all of that. There could have been a catalyst with a silicon-based life. Like there's ongoing crazy work right now that somebody actually took basically objects that were inanimate and they had the capability of making them move. So technically it's ambulating life, but it's not alive. And so the pathways for life that we know right now, it's really completely biased by what we experience here on Earth. So it's, I'm not going to discard it. There's not evidence, like if there was evidence against it, I would immediately say yes. Like based on Earth, no, but there's not enough evidence to say no. I mean, again, I'm not a biologist. There's a biologist here. Well, you're a biologist, but don't kill me. Yeah.
So Ganymede has more water than Earth, right?
Mhm.
So why isn't it being considered?
Ganymede, the tricky part about Ganymede is it has a very thick shell. It's like crust slash shell, so there's a lot of silicates, so it's rocky and ice. So in order to be able to go down into, it's going to be very hard. It's easier to go through ice. We still like kilometers thick the ice shell. It's like I didn't do justice, but so hard to be able to go down there. So the lander concept that I mentioned for Europa, we didn't have the toolkit to go further down than about 2 meters. And so you have, let's say, 2 kilometers thick crust. If you don't have the instruments for it, that would send people with equipment and all that. Starting to get sci-fi. I know, but yeah, Bruce Willis. Yeah.
How are we convinced that we can sterilize the spacecraft from our transport and they've earned Cassini up in atmosphere for that reason.
Yep, that's a fantastic question. So right now, one of the aspects that I work on is planetary protection. So the biggest thing that I'm trying to research is we're gonna send something that's gonna drill into somewhere, do something somewhere else. We gotta make sure it's as sterile as possible. Now, on Mars, it's a great example. So on Mars, I'm trying to calculate the depth at which microbial life may survive. And so let's say your mission is not astrobiology oriented. Let's say you're going to Mars because you want to extract water. That's what's possible. There are planetary protection protocols in place to say you cannot go at these depths because you cannot sterilize your equipment. And there are bacteria that can be dormant in the vacuum of space. They're not alive. If they arrive at the right temperature, like in a place that the temperature is adequate, then they eventually can move and come back and start, reproducing. So it's not that it's not going to survive. It's very likely it's going to survive. I I would say for the most part, there's a lot of work being done nowadays to do heavy sterilization to the point that there are certain labs or institutions, for example, UC Berkeley has a space science lab. They send all their spacecraft to either like NASA or other institutions to sterilize as much as possible, right? There is a possibility that like they'll put thing on. Um, I guess the best thing that we could hope for is to see the environment at which any possible detection has been made. Yes.
What causes the hotspots on Enceladus if the crust and if it doesn't have plate tectonics?
Right.
How important do you think plate tectonics is to like foundational building block? That's why it's called chaos.
Yeah. I mean, on Earth, plate tectonics is super important, right? For like a lot of biomass gets trapped into plate tectonics, and at those gradients, they survive. Like the temperature is ideal for microbes to survive. Believe it or not, there is tectonics. It's just not crustal like terrestrial tectonics. There's ice tectonism and cryovolcanism. So it's a different kind of animal. It's just ice acting as if it was like actual, terrain like Earth.
This is like subduction zone.
Yeah, yeah. Like you have shifts of basically icy plates that move around. And so the hotspots will definitely you will have a thermal gradient that is gonna shift depending on that. So it's very important. And so I think one of the interesting features of that specific moon is it has the tiger stripes. There's like these stripes and they're likely to be caused by these hotspots. And those are sort of like your targets for kinks. Like that's the place you want an orbiter to orbit continuously, possibly. So yeah, it's very important.
So you mentioned that you didn't think there was much life on the surface of Mars due to like sterilizing radiation. The two places that come to mind are at Jezero Lake, the shelf of the crust. What about the areas of the Eurasian crust that are like shielded by the UV radiation of the ancient delta, as well as home plate from the previous land over the time there was a microbial set they thought where they wanted to run up at spot, but they didn't want to send it back because it was like on the surface of Mars.
So in order for you to be able to survive experimentation wise, microbes need to be buried at least 2 meters below the surface. The turnover lives for microbes at 2 meters is usually about 5 million years or above. Anything above that is complicated because it's just galactic cosmic rays and what's called solar energetic particles just become that hard and just like constantly killing. Now, there is a caveat to it. If there is ice closer to the surface, if it's shallower, it actually works as a shield. Ice is a really great absorber of these high energetic particles. But we go to the problem of temperature. Ice is frozen, and if the temperature is not high enough for microbial life to survive, we found ice, but no microbes.
What about using radar? They've already built that in, but to isolate places where there could be potential sites, right?
That's like the question.
Yeah.
The Mars Reconnaissance Orbiter, which is still working right now, it actually has a radar instrument, and it's done a lot of good work to try to map the shallow subsurface, and they've been able to detect specific regions that have ice. The problem is, the resolution of the data set has not covered the entire